In here, I import a step file for the linear check to the software. Let's try to define it as external joint. And you can see here the position is not correct for the model. So let's try to move it for the first step. You choose the whole model and click the triple, and you can move it. And then we need to separate this model for two parts. The first part is the moving part, and the second part uh, is the check, is the physics check. So we need to find the model in here to define it as separated for two parts. But it's better to do this in the in the software like the SolidWorks, because it's a little hard to do this in the Turing Camp. But the model is, but we also can do this in the Turing Camps. We choose all the parts belong the linear check of the check. We almost separate this model for two parts, but it's not very exactly because it's a hard way to do it in the in the Turing Cam. So it's the work is better to do it in the 3D software like SolidWorks. So the next step, uh, we rename this part as J1. This part is a moving part, so we define it, rename it as J1. And this part, we renamed it as base. The name has been physics, in, and then we assemble these two parts. We can give a name for it as a rail. So right now we have a model. Its name is rail, and then we have two parts. This part is J1 for moving, and the physics part for the base. Then we can start to define a model for the external axis. So in the bar, we can choose the customer define and define mechanism. So This is the model we just rename and click the next step. And only one axis. And next step. For, for the time, we choose the guideway for that one. We choose the branch coordinates and move the branch coordinate to this uh, this interface. So we choose the move to face center. And then we choose the join J1 direction. In this model, the J1 need to move in the left and right side, and it's only one direction. For the one direction, the z direction of the coordinate is moved for the one direction. So we need to rotate the z direction in the left and right side. So we choose it to move 90 degrees. And then in here, we choose the J1. The axis type is trans update. And we finish the config. Or there's another steps. There's another setting. Setting the limited for the gateway. And it's a linear track, so we set it as in this model we set it as 9 meters. It's too long, but uh, the limited is depends on the model you're setting. So in that way we can define the model like this. And in here there's a this is a part left in here. It's because of the seam. of the parts we separate in the first step. In this software, because I separate is this one is not very good, so is some parts they don't follow the join one. They state at the guideway. So that is the part, but that is a way to define a guide weight. And when we finish the def the define of it and we save the external axis model. You just choose it, and then right button click. Here, save custom robots. I give a name for it. And for the positioner, we can we also in the same way we can define the positioner model for it. And right now this positioner model is not defined, so we cannot route it. And and it's same for the guide weight. We can define the model for the positioner. In this sim, I try to delete other parts. We only use one positioner to define it. And in the same process, we separate the positioner as two parts. One part for the physics part, and second part is the joint one. They will rotate. So we choose the part for rotate and physics to separate it. Let's check the parts again. Right now we separate this positioner as two parts. Is same to the guide weight, and we rename this visit part as base. I rename this part as joint 1. And we put these two parts as same parts. We rename this the whole part as positioner. Okay, let's start the define process. We choose the positioner model as step, and we choose the positioner type as a positioner. Then we define the flange of the positioner. We move it as the center of the plates. So we move it to the face center of the frame, and then we update, and then we choose the join once direction. Because the join one is rotated at the positioner, so we choose a center. We choose the rotate center in, can choose it in this space. And the z direction is the rotate direction, so we need to, and the blue one is the z direction. We need to choose and rotate the z direction in the rotate direction, so we rotate as 90 degrees. Okay, and updates. So we can try to move the base of the positioner. You can choose this interface. Oh, sorry. Firstly, we need to, it's better to choose the base of the positioner, and then choose the flange. J1. Sorry, flange. J1. So, and also we need to set the limited of the rotation. You can set it as minus 1916 degrees. Okay, in that step, we can we finish the define of the position. and then we can rotate. Also, we can save this positional model. Right now, we finish the defines of the guide weight and the positioner. And right now, we can try to build the sim of the whole station. We can import the models. We just made just right now, just now, and we can import the rail because the base of the guide maybe I cannot not uh, define the base, so it's the base point is not correct. Yes, okay. Now I did import guide weight models, and the original one I can you can delete it. We also delete this robots. We already import guide weight model, then we can import robots. And also import two positioners. Then we import other positioner. Also move to the positioner to the same position of the original one. Then we can delete the original model. We just use the positioner we defined just now. Uh, then we can get two positioners and one guide weight. Then we can try to install the robots in the guideway base. rotate for 90 degrees. So right now we move the all the parts to correct position. And then we can create a link for the between the robot and the guideway and the positioner. So create external short links. Right now, and in the right side, you can see there is three externals in below the robot arm. And the next step, we need to grab the robot. Here right now, the robot is at three external axes, but the robot need to move with the guideway. So we need to use the guideway to grab the robot model, and then the robot model can follow move with the guideway. So right now we finish the positioner and guideway config, and then we can try to import welding torch, import a tool for the robot. For now, I can I just find a welding torch in the libraries. Also, you can define your own welding torch or other tools. Right now, the working part you can see is not follow the positioner. If I move the positioner and the workpiece is not moving with the positioner, so let's set it as a part of it, and we choose this part and catch by by this positioner, and let's try to move. Try to catch the part. Okay, so the second positioner is catch the working piece. This part, let's try to release it. Catch it. The position one, catch the part one. Okay, right now we finish all the environment config with uh with one robot and welding torch and one linear check and one positioner. The second positioner config. Then we can try to setting the points, the simulation points of the robot or catch the points. Mm, in here we can, for example, set the robot in. We can add a point like this rate and move the robot in the panel. Then we record the second point. Also, we can use the software to get the path of the robot. For example, in here, you can click the create path. And then we choose a type to get the points, get points. For example, we just choose the first one along an edge of a base. And here we can choose a line to get points. Okay, we can choose this line. And then choose a face. And then choose an edge. Same as the first line. Okay, in here we can get the points of this of this park. And in here, if we want to change the direction of the point that we get in here, we want to change the direction of, for example, rotate the welding torch, we can change, rotate the path. We can choose the path we get by software, and then rotate. Yeah, we choose the z-axis position, and the points of it is the the direction of the coordinate is changed by the points, and then we can and we can try to move to that point. And if we want to change the direction of the points, we can rotate. Sorry. Can rotate. We can try to rotate the z-axis as 180 degrees. And you can see the welding torch direction is changed. Okay, let's try to combine the hold passes. Okay, in that way, the points is only moved by the robot itself. If we want the robot move the robot arm and the external axis as at the same time, we can choose the mm, we can we can try to choose the synchronics with the mechanism. Okay, if we want to move by synchronic, we need to another setting to set the robot moving synchronic with the external axis. But we can try to set it later. And right now we get 2 points. We set 2 points in here and get a pass by the software of this one. And if we want to output this trajectory to a robot program. You can click the output job and choose the TCP of the welding torch and create a file. And then here is the program of the point we just set. And we can export this program to a robot's file folder, copy to the real robot and try to move. So that is almost all the process of the Turing Cam software operation by this application. One linear check and two positioners.